All righty. So hopefully you have printed out a periodic table and you got your colored pens or highlighters or maybe crayons because we're going to go through just some important ideas. And so there are important ideas that we looked at last week with families of elements. And starting Wednesday, we're going to be talking about so atoms have a tendency to form ions, and the ions they form are predictable, and you don't have to memorize them all because they are found on the periodic table. There are some you have to memorize, but you don't even have to memorize them. You just have to know they have more than one choice possible and what the choices might be. So yeah, this is an important review and foreshadowing of the periodic table. I'm really grateful that you're here. I don't know. I had a bad day yesterday. I was just feeling a little discouraged. And then I sent out the remind this morning saying basically, okay, 25 out of 55 people have watched the videos. Why do it now? And then I thought, okay, so don't get grumpy because that makes people not want to come see you. And yet you're here. So I'm feeling encouraged. Thank you. I just want to state for the record that when I make an assignment, I'm doing it because I think it's good for you, that I do not want to waste your time. I am not assigning things or expecting things that I think are bad for you in the long run. So I want you to remember that I'm kind of like, not your mom, because sometimes moms are sort of like, you should, I have expectations. I get that. My kids tell me. But think of me as like your mom's sister. Like I'm a person who loves you and wants good for you. And I appreciate when you are present. And when I give an assignment, the goal of the assignment is for your growth. It's for your benefit. So I'm super grateful that you're here. And I'm going to go ahead and jump in. And then if you just arrived, I was telling people, make sure you have a periodic table and something to write on it with. Okay, so I'm going to screen share. Aw. Thank you. Okay, here we go, screen share. The first thing I would say is the periodic table is a tool, and it is a tool that contains a lot of useful information and gives a lot of information about trends. So there's so much in chemistry that we don't have to memorize. Once we become familiar with the periodic table and the power of the periodic table, we can use it. And it is always available. Never on a quiz or a test in chemistry will you be asked to solve a problem without a periodic table. Okay, so that's one thing. The next thing is we're just beginning to look at this idea called periodicity. Periodicity is an idea that things behave in a certain way based on a pattern that is regular. So there's a period, and then there's another period. If you think of like a wave function in math, there's a repeating pattern, and the periodic table is organized to help us understand that. So the first thing is when you see a group, and a group is just a column. Okay, I'm going to have to take hydrogen out of this one because the weird thing is hydrogen, it's kind of in the wrong column here. As you know, this is a group of metals that have a family name. What's the family name? I think you saw a video on it a couple weeks ago. I'll give you a minute to do that. I'm just going to write the word here that I've shown you. Columns are groups. So this will go better. I mean, I could just say all the things, but these are things that I think you know. So if you have a chance to say them, I think it's better for your learning. Remember, I'm Aunt Sue. You're Kim Aunt Sue. You're Kim Aunt Sue, the one's good for you, the good aunt.
They're alkali metals.
Yes, they are. So this group has a family name, and the family name is alkali metals. Why is hydrogen not part of that?
Because it's not a metal.
No, it's not. Good job. Yep. A+. Okay. So some families have names, and there are 4 names that you need to know. So right now, I just want you to think about different columns, families, groups, and think about the names of the 4 that you know. Okay, does anybody think of another family, group, column? Name?
There's the halogens.
Yes, here they are. Bloop, bloop, bloop. Other groups?
Noble gases.
Super important. In fact, we're going to spend a lot of this hour just talking about noble gases, like, oh, yes. Okay, noble gases. They also have another name. Noble gases are noble, like better than the commoners. What makes them better than the commoners? In chemistry, it turns out that they have a perfect electron configuration. They've got the perfect number and arrangement of electrons. And because of that, they don't need to gain or lose electrons. They can mix with commoners. Xenon is like Prince Harry, radon, krypton. You know, those are the ones that hang out with commoners sometimes. I'm watching The Crown. It's really good. But they don't have to. And the reason is because they are perfect. How are they perfect? In their number and arrangement of electrons. And that makes them inert. Inert is a fancy...
It's just 3.
Say it again?
It's just those 3 that you like squared.
Oh, pretty much, yeah. Radon is its own thing. Radon's radioactive. Okay. But xenon and krypton will form compounds. They don't need to because they're perfect how they are, but they sometimes do. Thank you for talking. Okay, so the noble gases are noble because they have the right number of electrons. They're gases because they just are. And they're inert, and inert is a fancy word that means unreactive. The noble gases are unreactive. Why are they unreactive? Because they have that perfect number of electrons. 2, 10, 18, 36, 54. Those are the perfect number of electrons. Okay, there is another group that has a name. Somebody else? Works better if you talk.
Sorry, what's the question?
The question was, those are 4 groups that have names, but those are 3, but there is a 4th one that you need to know.
The alkaline earth metals group 2.
The alkaline earth metal.
Exactly. So let's highlight those. Okay, so alkaline, not alkali, earth metals. Okay, so those groups have names, but there are other groups that are important. And so now I'm just going to look at some groups that don't really have names. So this group here under carbon could be the carbon group, the carbon family. And this group here under nitrogen is the nitrogen family. And oxygen is the oxygen family. So for the ones that don't have names, we just say pick the leading element, and the leading element is simply the one at the very top. Oh, I've heard 2 people leave. It makes me so sad. Am I boring you? I'm sorry about that. I'm going to keep going. But yes, I've heard 2 doorbells saying they're leaving. Anyway, so these are also groups, and groups are important. They don't have family names, but it still matters. So each of these is a group. The thing that makes them a group is that they have a similar arrangement of electrons. Electrons in most chemistry is super important. We don't usually look at the nucleus much, but we do look at electrons. So some of these are metals and some of these are non-metals. And then of course there's the metalloids. We're going to ignore them today. So go ahead and on your periodic table, remind yourself where the metals are, the non-metals, and the metalloids. The metals, non-metals, and metalloids. We talked about properties. What are some properties of metals?
They're
They are shiny. There's a word with starts with an L.
Lustrous.
What else?
They conduct heat and electricity.
Yes. Good. What else?
They can be formed into like wire.
Mhm. Yeah, they can be shaped, they can be hammered or pulled into sheets or pulled into wire because metals stick together with a sea of electrons. They're very malleable. That's important. Yeah. What else? So right now you don't have to speak, but everybody has an opportunity to think through properties of metals that they know. And then if you're like complete blank, I don't know any properties of metals. Oh, that might be important because this is the second time in our class that I'm mentioning properties of metals. So that is a thing you need to know. Make a flashcard. Okay, so there is another property. I don't want to leave my bike out or my tools out in the rain. Why?
Don't rust.
It's that they either gain or lose electrons, but I can't remember which one.
Yes, they rust, they oxidize, they lose electrons. Those are all the same idea. Yes. So metals lose electrons easily, and that's an important idea. And not metals are the opposite. So what would you say about metal, non-metals, which I guess are green?
They would gain electrons easily.
Mhm. So we're focusing on that, and this is leading us into the next chapter in the next week. This is a big idea. We're headed into an idea called nomenclature, which is the system of naming things. And so we're going to start to look at compounds, and some compounds are made of metals and nonmetals. We call those ionic, and some compounds are made of nonmetals only, or maybe metalloids with nonmetals, and we call those covalent. And they stick together different ways. There's two important things: ionic, electrostatically attractive, positive and negative, opposites attract. Covalent, electrons are shared. So this is where we're headed next week. But we're just starting with the periodic table and its periodicity. There's some patterns, and we can use it to make predictions. Super important. Okay, so the important idea today on the periodic table is metals lose electrons easily. My favorite metal when I'm talking about this is sodium. So right now, I just want you to tell me how many protons, neutrons, and electrons does an atom of sodium have?
11.
11 protons, yes. An
So then 11,
atom. Go ahead.
11 electrons.
Yeah, 11 protons means a plus 11 charge in the nucleus, and 11 electrons means a minus 11 charge outside the nucleus. Perfect and good. What about neutrons? Do we know?
Not without the mass number.
Thank you. Yes, it depends on the isotope. So I don't know how many neutrons. What I do know is neutrons are neutral. Okay, so an atom adds up to 0. For an atom, the net charge, the overall charge is 0. But sodium tends, as a metal, to lose electrons. And the question is, how many electrons will sodium lose? And the answer is 1. Why? When sodium, with its 11 protons, plus 11 charge, and some neutrons, but they're neutral, loses 1 electron, it only has 10 electrons to be like neon. Neon is so cool. Neon is the kid in 2nd grade that's like, yeah. Well, Neon doesn't know it's cool. But everybody else is like, whoa, did you see those shoes? Did you see that backpack? You heard how Neon said sweet? I'm going to start saying sweet. So Neon is the cool kid in 2nd grade. Neon, the noble gas, is a role model for us. So with 10 electrons, that means a minus 10 charge around the nucleus. So it adds up to plus 1. When sodium forms an ion, sodium forms a plus 1 ion, always. Why? Because when it does that, sodium is isoelectronic with neon. Iso is a word part that means same. Electronic has to do with the number and arrangement of electrons. And neon is just perfect. Oh my gosh. 10 electrons. It's so stable. Okay, so sodium, when it loses electrons, because metals lose electrons to become more stable, loses one. Why? Because when it loses one, it is isoelectronic with neon. So we're just gonna take a guess. Here's potassium with 19 protons and 19 electrons. How many electrons do you think potassium will lose?
1.
Why?
Because it wants to be like the noble gases.
Yeah, which noble gas would it be like?
Number 18, which if I recall is argon.
Exactly. So the things in third grade, they don't want to be like the cool second grader. Metals lose electrons to become stable. And if they can lose enough electrons to be stable like the previous noble gas, they do so. Okay, so that's metals. Metals lose electrons. It's a property of metals. How many electrons depends on where a thing is on the periodic table. That's part of the periodicity, which is a fancy word for the regularity and the arrangement on the periodic table. So right now, I want to erase this unless anybody has a question. Okay, and we're going to look at magnesium. So here is magnesium, 12 protons, some neutrons, depends on the isotope, 12 electrons, overall charge is 0. That is a magnesium atom. However, when magnesium becomes stable by losing electrons, how many electrons will it lose?
I don't know, but I want to say 2.
Perfect. 2 is the right answer. Why would it lose 2?
Well, it's in the second row, and if it wants to be like neon, it would lose 2.
Yep, exactly. So magnesium has 12 electrons, but if magnesium loses 2 electrons, it will only have 10. Plus 12 minus 10 equals 2. The overall charge is plus 2. Magnesium ion is magnesium with a plus 2 charge in the upper right-hand corner because it's lost 2 electrons. We've all had a friend that was dating the wrong person. You're just like, oh my gosh, let them go. That is, you just need to break up. That's not right. And when your good friend whose personality changed because they're dating this person finally lost something negative, they became more positive. When you lose electrons, overall you're more positive. And that's what's happening here. So there is a pattern, and the pattern applies to the representative elements. So here we have a different periodic table. And right now this one is focusing on, we have group 1, they would lose electrons to form +1 ions, even hydrogen. Group 2, they would lose electrons to form a +2 ion, all of them. And then here is group 3. So in group 3, they're not all metals. Which element in group 3 is not a metal?
Boron.
So I'm not looking at boron, but the metals would tend to lose 3 electrons to become stable. So metals lose electrons to become stable. Now we're going to talk about this group here, which is the transition metals. And then within the transition metals are something called the intertransition metals. If I cut my periodic table right here, and then I opened it up, this part here, I could take that piece. And this part here, I could take that piece. And that is where this block would fit, is within the transition metals. So here we have element 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, and 72. So we move it down there, this group called the intertransition metals, just to kind of make it fit on a landscape 8.5 by 11 page. But they are transition metals within the transition metal group. That's why they're inner. Okay, so all the transition metals which includes everything here and everything inside there, those all are metals that lose electrons to become stable. But how many electrons they lose, we can't predict. And so next week we'll talk about what we observe. But for main group metals, we can make a prediction, which is what the charge will be as an ion. Why do ions form? Because they're more stable. Why are they more stable? Because they're like noble gases in their electron arrangement and number. There is a word you find, and the word, as you're reading, would be uncombined. And you'll see a sentence like this: sodium is never found uncombined in nature. And I think sometimes as students, it's easy to go, okay, I don't even need to know what that sentence means. But it really is important in chemistry as you're reading. Yes, you need to read everything. And as you're watching videos, yes, you need to watch all the videos. That when you come up with a sentence that doesn't necessarily make sense to you, that you track down what it actually means. You find a way to put it in your own words. So does anybody have an idea that you are willing to share about what the sentence means? And it's okay if you don't, and it's okay if you do and you're wrong. It's all okay.
Does it mean that sodium is never like an element? It's always a compound with something else?
Exactly.
Or, yeah.
No, that's perfect. So you never find the sodium atom in nature. Why is that? You do find the ion, and there's only one choice. It has to be positive, because sodium's a metal. It has to be +1, because sodium loses one electron to be like neon. So why do you never find sodium uncombined in nature? And the answer is because it's not stable. You know, why don't cows fly? It's not a stable way for a cow to be. Like it's unlikely, and we never see it because it's unstable. So that's what's happening here. Sodium is never found uncombined in nature, which means it's found as an ion, and the ion is combined with another ion. Like here we have sodium chloride. Sodium is a cation, and cation is a fancy word of saying positively charged ion. And it combines with chloride, which is an anion. An anion means negatively charged ion. Now, it's not that sodium has to be found with chloride. It's just it has to be found positive because that's stable. And then it finds something negative to also make it more stable. Okay, so let's talk about chloride for a minute. Actually, I want to talk about fluoride. Here's fluorine. Fluorine is a nonmetal. Nonmetals gain electrons to become more stable. How many electrons will fluorine gain? 1. Why?
To be like neon?
So
maybe.
The atom of fluorine has is in group 7 and has 7 outer shell electrons. So the group number has something to do with the arrangement of the outer shell electrons, which are important. There's something magical about having 8. So when fluorine gains 1 electron, it still has 9 protons, or it wouldn't be fluorine. It has some neutrons, which are neutral, or those protons couldn't stick together in the nucleus. They would repel one another and the nucleus would bust apart. So neutrons are nuclear glue, they're necessary, and certain numbers make the magic happen. And then if fluorine gains an electron, it has 10 for a negative 10 charge, plus 9 plus 0 minus 10 is -1. So fluorine becomes an ion, fluoride. In order to become stable, nonmetals gain electrons. How many does it gain? 1. Why? To be isoelectronic with neon. There's something super special about having 10 electrons. Alrighty. And we have a word for a positively charged ion, we call it a cation, and a negatively charged ion, we call it an anion. And next we're going to talk about how cations and anions stick together. That's all I got. Does that make sense?